Good morning, everyone. My name is Deepak Chaman from Gorakhpur, Uttar Pradesh. Today we have learned about the Unit 1 of Basic Electronics Engineering from all branch of BTech first year. Now the Unit 1 is Semiconductor Diode application special purpose of two terminal device. So basically we cover all the topics related to this chapter, this unit. Now the first we start from the conductor. What is conductor? Conductor. Conductor. Conductor, which means they flow इलेक्ट्रॉन इजीली, जिसमें इलेक्ट्रॉन बहुत आसानी से फ्लो हो जाए उसको हम बोलते हैं कंडक्टर. दे फ्लो इलेक्ट्रॉन इजीली. एंड व्हाट इज इंसुलेटर? इंसुलेटर दे हैव no flow of electron. What is semiconductor? They flow electron with respect to time and many other factor of affecting. So overall, this is valence band, this is conductor. In conductor, both the conduction band and valence band are connected to each other. So the electron flow easily from valence band to conductor band. This phenomenon is known as working on the conductor. The energy gap is zero in conductor. So this portion, the gap between both are Eg is equal to 0. If Eg is 0, then the flow of electron is easily from one place to another place without any hindrance are known as conductor. Let it go to insulator. This is conduction band. Valence band. The gap Eg is equal to 5 electron volt. The gap between Eg is very high, so electron cannot jump through conduction band. So in this condition, the electricity cannot flow from one band to another band. So this is known as insulator. In insulator, they have no current pass through it. Conductor have iron, copper, gold. Insulator have rubber, wood. Now the second one is semiconductor. This is the most important in electronics because semiconductor is the main things in, because they use in laptop, tablet and many other places of it. Semiconductor are basically germanium, silicon. These two are the most important. Germanium and silicon is made up of semiconductor. Semiconductor conductor have also conduction band, valence band electron flow from valence band to conduction band. Each electron gap is 1 electron volt. The gap is 1 electron volt is so less, so we can say that the flow of electron from valence band to conduction band is very easy. Zener and others. This is the basic difference between semiconductor of have two parts: intensive, extensive. Intensive have pure semiconductor without any mixture like silicon and germanium. Extensive semiconductor have doping semiconductor with mixture like Zener, avalanche, and so many on. Now let me proceed. Now we proceed from the forward bias of PN junction. What is forward bias? If the P type of semiconductor is connected through positive terminal of battery and N type of semiconductor is connected to the negative terminal of body, so that we can say that this is P type connected in positive, N type connected in negative terminal of body, battery terminal of battery. In this condition, we can say that if P type of semiconductor connected in positive terminal of battery and N type connected in negative terminal of battery, so we can say that this is forward bias. P type semiconductor have negative charge high, holes are less, and N type conductor have positive or high and electron have. If the battery is connected from this to this, the electron passes through this and they jump from this. This is the working phenomena of PN type. P forward bias of PN junction. If the sign changes positive, negative, N type, P type, this is known as reverse bias semiconductor. NP type. NP type semiconductor. If the first P type of semiconductor is connected through negative and N type semiconductor connected in positive, so in this way we can say that this is reverse bias of PN type semiconductor of reverse bias of PN type junction. Characteristics of forward bias and reverse bias. The characteristics of this is the graph of forward bias and reverse bias. If PN junction, PN type semiconductor connected, then the graph is continuous growth in exponential form of the B output is 0.3 is for germanium, Je is for germanium, and if the graph is plotted from 0.7 each, Si is equal to silicon. If the PN type semiconductor follows in reverse bias, this is totally forward bias. Forward mass. If if the if we change the terminal of battery, they reattach reverse bias. This is reverse bias, totally reverse bias. If the semiconductor is zener, then they break. If the semiconductor is avalanche, they break after some time. This is the overall of characteristics of reverse bias. Conduction band. This is balance band. If the electron passes from balance band to conduction band, it passes this and this go back on that flow. This is the continuous phenomena is working on LED. If the balance band of electron flow from balance band to conduction band, on this phenomena, the electron glow and go back from this. This is EV. The advantage of LED. Proceed from vector diode and tunnel diode. Vector diode है working on reverse bias. What is reverse bias? If P is counted from negative and N is counted from positive, this is forward bias. This is reverse bias. And in this have a lens. Lens added from this negative positive goes from this to this. This is totally, and this is react like capacitor. The capacitor formula is C is equal to epsilon A upon D, where epsilon is equal to permittivity, A is equal to area, D is equal to distance between both. This is the symbol of vector diode. The formula is basically V directly proportional to D and D directly inversely proportional 1 upon C of capacitor. This is hollow space at dielectric. This is the overall of vector diode. Now we will proceed from tunnel diode. Tunnel diode working on forward bias. Forward bias, which means P is counted from positive and N is counted from negative. This is forward bias. Forward bias have two. This is conduction band, this is balance band. This is conduction band, this is balance band. If the electron is here, the electron jump from this to this. This is working phenomena of tunnel diode. This is basically on the working. If they shifted up on that condition, they react like this. Conduction, balance, conduction, balance. On that condition, the electron cannot flow from this. This is the non-working of diode. If they passes upward, this is working on forward bias. If both are in same position, they cannot flow from one to the other. This is the symbol of tunnel diode. This is highly doping. So on this condition, the forward bias is coming in a short form. If they weigh down, they jump sadly. The graph of this is so high. The graph means to rectify any signal. Rectifier are two types: half wave rectifier, full wave rectifier. So we can say that if these are sine wave, input, output become positive, 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 negative, positive, 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 negative. But in full wave rectifier, this is basically sine wave, positive, negative, positive, negative. Input, output become positive, negative, positive, negative. This is the basic difference of half wave rectifier and full wave rectifier. The half wave rectifier has only one positive, negative, negative, positive, negative, negative. And but in this positive, negative both are in same way. So that we can say that this is a more effective and full wave rectifier. This is transformer overall. This is two diode D1, D2, resistance, which means load. This is the figure of full wave rectifier. Basically, in this have working in blinking, and this is regular output, blinking output. Now we proceed from clipper. Clipper which clip the signal. This is the input signal, sine wave, positive, negative, positive, negative. This is circuit. This is diode, load, resistance. This is current. Positive, negative. If positive is there, on this condition, if the positive current going through it, this is working on for reverse bias. So reverse bias, the output becomes 0. On this condition, the positive becomes 0. If they replicate from negative, if sign have negative on that condition, they reattach forward bias. The forward bias on that condition, the graph show as such as they show from negative. Let the another example is this is sine wave is input. If positive, negative, load, diode. If positive going on there, positive, they work as forward bias. The diode is closed. On that condition, the graph becomes positive and positive. After, if the sign is changes, negative, positive, on that condition they break down. Overall, the negative charge is 0. This is the working of it. Now let us proceed from clamper. Clamper which shift the signal like upward and downward. This is a common input have Bm positive, Bm negative. This is output input graph like this. If this is a circuit, have diode, PN, load, capacitor. If positive going through this is charge. This is working as forward bias. On that condition, positive we can replicate to base. So this is on the base. After that, if follow negative, but this capacitor also charge. On that condition, they replicate from negative to Vm to positive. This is the working of clamper. Now we have proceed from the question. In the bridge rectifier circuit, the voltage Vs is equal to 100 sin 50t and load resistance 1 kilo ohm. Now we have solved on this. Vs is equal to Vm sin 50 omega t. Vs is equal to 100 sin omega 100 50T. R is equal to load current is equal to 1 kilowatt. W Vm is equal to 100. Vm is equal to 100. Omega is equal to 50. Now we proceed Im. Im is equal to Vm upon Rn is equal to 100 upon 1 is equal to 100 microampere. This is the peak value of current. IDC 2 Im upon pi 2 into 100 upon 5 is equal to 63.66 in a DC current. Now RMS Im upon root 2 Im is equal to 100 even root 2 is equal to 70.712 mA RMS value of voltage. Now PIV is equal to peak inverse voltage. P equal to Vm is equal to 100 microampere. Now recall factor 0.4282, efficiency 81.2. This is the numerical value of this question. Next topic for the voltage like doubler, triplet and quadrupler. This is basically voltage multiplier. This is also known as voltage multiplier. Or this is input signal has sign positive, negative, and so on. On that, this is a circuit of voltage multiplier. If we check, this is positive. Now let's solve this. Positive, negative. Positive, this is working on forward bias. This is working on forward bias, positive, negative charge. So we can see that D1, diode 1, diode 2, diode 3, diode 4, diode 5. Basically, D1 is short circuit because they follow current from this way. They cannot pass current from other side. So that minus Vm plus this is capacitor Vc1 plus Vc1 is equal to 0. So Vm is equal to Vc1. This is one equation. After from negative half cycle, changing the sign, negative, positive. After that, positive, negative, this is Vm, and second one is current passes from this way. On that condition, this is Vm from this Vm plus Vc2 minus Vc1. So on that condition, Vc1 is equal to 2Vm. This is 2Vm. On second half, positive cycle on this. Now change the sign. Positive, negative. They are working on that way. On that, minus Vm plus Vc3 minus 2Vm is equal to 0. On this condition, Vcm is equal to 3Vm. Similarly, Vc4 is equal to 4Vm and Vc5 is equal to 5Vm. Now, if they are working on doubler, from this circuit is doubler, 2Vm, 2Vm, 2Vm. This is from tabular because from doubler is equal to only 2Vm is equal to Vc2 tabular is equal to Vc1 plus VC3 is equal to 1 plus 2 is equal to 3 here. What triplet is equal to VC2 plus VC4 is equal to 2 plus 2 is equal to 4 D. This is the overall of